All right, so welcome to part 2 of Unit 4. So what we are going to do, sorry, I was like trying to find words. That was like really hard. Welcome to also being at home and trying to teach y'all and losing your brain cells a little bit. So what we're going to do today is we're going to now tie physical and chemical changes, right? We've already done that, to chemical reactions. Okay, we've already started doing that. And then we can go further because there's different types of chemical reactions. So that's going to be our main focus for today. And on the screen, you see a chemical reaction going down. We already looked at this, right? We have a precipitate reaction. And after today, you guys are going to be able to identify maybe what type of reaction could be going on here. Okay, so your objective for today is you're going to be able to identify or differentiate the 5 types of reactions by analyzing the structure of the chemical reaction. So we're going to actually have to look at those equations that we started looking at yesterday, okay? Or in the last video, I should say, okay? In your notes, you have this chart here, okay? You have the types of reactions. There's 5. You have a general description box. You have a general equation box, and then you have an example box. So we're going to go through all of these, okay? We're going to give you everything you need to know, and then we're going to move on from there, okay? So the first type of reaction I have is what I have called a synthesis reaction, right? And if you think of synthesis, to synthesize, okay, you might think of, oh, I'm creating something, okay? And it's the same thing. Synthesis reactions are going to take 2 reactants or 2 things and form 1, okay? If you guys have your reference table, your final exam reference table, in there, I forget what page it's on, you'll have the different types of reactions, and you're even given that same general equation, right? So synthesis is when 2 reactants come together to form 1 product, and my general equation is A plus B gives you AB, okay? An example of this is copper and oxygen, okay, where I have Cu, which is my A, plus oxygen, which is my B. They come together and they form CuO, or copper oxide, okay? Another way to think about this, let's think about people, right? We have A plus B gives you AB, right? You got Jay-Z plus Beyonce to give you the musical empire of Jay-Z and Beyonce, right? So they're coming together to form 1 product, right? The next type of reaction we have is decomposition, okay? And if you think of the word decomposition, you could think of decompose or breaking apart, breaking down, right? And so decomposition is just the reverse of synthesis, okay? It's when 1 reactant then breaks apart into 2 products. Okay. We have a simple general equation that's given to you. It's also here, which is AB breaks apart to give you A and B. Okay. And an example of that, okay, is over here. Okay. H2CO3 reacts to form H2O, which is water, and CO2, which is carbon dioxide. Okay. So we have this example, okay, which is actually this. This is the carbonate, okay, which is soda pretty much, right? That's happening. We can also think about this in, again, celebrity terms, right? We had Travis Scott and Kylie Jenner. They were together. They broke apart to be just Kylie and Travis Scott, okay? So it's pretty much breaking apart. Okay. The third type of reaction we have is single replacement. Okay. Single replacement is, right, if you think about it, what is replacing, right? You're taking someone's spot or you're taking something's spot. And single means 1, right? So an element is replacing another compound and only 1 element is going to change. So 1 element going to be ending up single. Okay. My general equation is A plus BC gives you, or reacts to form, AC plus B, right? You see that it's A, right, is going to replace B, okay? So only one thing is being replaced, and B ends up being single, okay? An example of this is actually kind of looking at like rust, right? I have Fe, which is iron, plus H2O is actually going to give you hydrogen gas plus iron oxide, okay? To look at that in celebrity couples, if you haven't caught on yet, we can think about this beautiful example if you guys know anything about Brad Pitt, right? Brad Pitt and Jennifer Aniston used to date, right? Angelina was single, okay? Angelina kind of swooped in. Then Brad Pitt and Angelina were an item, and Jen Aniston ended up single, right? So pretty much just switching that person out, or switching that element out, okay? So it's a single replacement, okay? The next type we have is a double replacement. So replacement, again, still means to replace. So you're going to be trading or switching partners, right? But a double replacement instead of just one element replacing another, both elements, okay, are going to be replacing each other. So pretty much what's happening is I have ions in this situation and they're trading partners, okay? And sometimes a precipitate will form. And that's the example that we looked at, right, at the very beginning of this video, right? Double replacements is AB plus CD forms or yields or reacts to form AD plus CB, right? So A is going to take the spot of C, right? And C then takes the spot of A. Okay, so there's going to be ions that are both switching, right? So each partner switches, right? An example of this is CaCl2 plus AgNO3 yields CaNO32 plus AgCl, okay? So Ca and Ag, right? Ca's partner is switched, Ag's partner is switched, okay? Celebrity example, right? Selena Gomez and Nick Jonas used to date, okay? Jay Biebs and Miley Cyrus used to date. Then they kind of did a nice little switcheroo to Selena Gomez, okay, and Jay Biebs dating, and then Miley Cyrus and Nick Jonas dating, okay? Obviously, that is no longer true, seeing how two of those lovely celebrities are now married. One of them was married and now divorced, okay? But back in the Disney days, when they were all on Disney Channel, they kind of did a nice little switcheroo, okay? That's a double replacement reaction, okay? The last type, oh, I didn't even change the title. That is so unfortunate. Let me change that. The last type of chemical reaction we have is combustion. And if you think of something combusting, okay, it's like catching fire, okay? So combustion, all it is, it's called a hydrocarbon, right? So hydrogen and carbon, like covalent bond, is going to react with oxygen gas and it's producing carbon dioxide and water, okay? So my general equation is hydrocarbon plus O2 yields CO2 plus H2O, okay? The biggest thing about combustion is you are always going to have carbon dioxide and water as your only products, okay? Every single time. So if you look at a reaction and you have CO2 and H2O as your products, you can automatically, most of the time, assume that you have combustion, as long as, if you flip back to the reactant side, you have a hydrocarbon, meaning there's carbon and hydrogen in your reactants, okay? So an example, a hydrocarbon could be wood, mixing it with oxygen that produces the flame. It's going to be water and carbon dioxide, all right? So what we're going to do is I'm going to put up 10 different chemical equations, and you guys need to decide the type of reaction it is, and you're going to copy this down in your notes, okay? I will pause the video so that you guys, or you guys can pause the video so you can take some time to figure it out. I'm going to rapid fire through. Okay. So, wow, that's really annoying. I didn't realize I still had all of those. Anyways. Okay. So this is my first reaction. Okay. Pause it. Look at it. Okay. When you think you know what it is, let me know. But this is a double replacement, right? Because Na is switching partners, right? So Na is going with NO3, K is going with OH. So this is an example of a double replacement. I have CH4, 2O2 yields CO2 plus 2H2O. Pause your video. Copy down what you think it is. Your answer is combustion. All right. We know that because CO2 and H2O are my products. And if I look back at my reactant side, I have a hydrocarbon up in here. Okay. I have Fe plus NaBr gives you FeBr3 plus Na. Again, you know what to do. Pause the video, look in your notes, see what we got. In this term, we have a single replacement reaction, right? Fe is taking the spot of Na, right? And Na ends up single. So that is the great example of a single replacement reaction. Okay, super similar to the Jen Aniston, Angelina Jolie. Okay, CaSO4 plus MgOH2 gives you CaOH2 plus MgSO4. Pause your video. We have a double replacement reaction going on here, right? They're both switching partners. Ca is now going to be with OH. Mg is now with SO4, so they both switched. So I have a double replacement. Next one is Pb plus O2 gives me PbO2. You guys know the drill. In this case, I have a synthesis reaction, right? I have an A plus B gives me AB, right? Two different reactants are coming together to form one product. So if I only have one product, one combo on my product side, I can assume it's synthesis because I have two things coming together to form one. I have Na2CO3 gives me Na2O plus CO2. I have a decomposition reaction, okay? I have one reactant breaking apart into two products. I have an AB gives me A plus B. Al plus HCl gives me AlCl3 plus H2. We have a single replacement because we have one that is single replacing another, bumps it out, that one becomes single. I have H2 plus N2 gives me NH3. We said this before, if I have one product, I am synthesis. H2O gives me O2 plus H2. We got decomposition because it's one thing breaking down into two. And last but not least, we have CH3OH plus O2 gives you CO2 plus H2O. We said that if I have carbon dioxide and water as my products, I can really honestly most of the time assume combustion. If I go back to my reactant side, I see carbon and hydrogen mixed together on this side with some oxygen. Whoops. So I can say that I have combustion. All right. So based on that, reflect, look at your notes, make sure you understand kind of the 5 types of reactions. Don't worry, there's practice coming at you live soon. Okay, answer these following questions. Okay, it's actually only one question. What are the 5 types of chemical reactions? And I want you to include the general formula and an example. Okay, this should be at least 5 sentences, if not more. Once you do that, okay, we're going to come to the practice. Okay, again, there's going to be an online assignment. And then the Mastery Connect quiz from the previous lecture is going to be combined with this one. It's going to be due April 6th at 11:59 p.m. So keep that in mind. And otherwise, you guys are good.